Hello student, my name is Harendra Kumar and I am going to teach mathematics. Today we are going to learn adjoint of the matrix, which is topic of class 12th and which is crucial for the JEE examination. So let's begin. Adjoint of the matrix. Students, for knowing adjoint of the matrix, it is primary condition that the matrix should be a square matrix. What is square matrix? A square matrix is a matrix which has same number of rows and same number of columns. Means a square matrix is a matrix in which number of rows are equal to number of columns. So first point, to define adjoint of matrix, it must be a square matrix. Now we define some more concept, one more elements. Let understand minor of matrix. Minor is defined for each of the element of the matrix, a square matrix. So Mij is equal to determinant obtained by deleting ith row and jth column. So let's take an example. Let A is a matrix having element 2, 1, 3, 4, -2, 6, 0, 2, 1. This is a matrix. If we want to determine the minor of this element, so we can write M11 because this element is in the position of first row and first column. So M for minor and 1 for first row and first column. So if we delete this row and this column, we will remain with -2, 6, 2, 1. So this determinant is called minor of that element 2, and we can calculate this. As we know, -2 into 1 minus 6 into 2. So this is equal to -2 minus 12. So this is equal to -40. So we can define one of the minor for the element in the position of first row and first column. Now we can also define the minor for other elements. Let's see for other element, that is 1. So M12, M12. So for M12, we delete first row and second column. If we delete first row and second column, we will remain with 4 0 and 6 1. So we write 4 0 6 1. So this determinant is called minor of the matrix. Okay, student? So we can calculate this 4 into 1 minus 0 into 6, that is equal to 4. So in this way we will able to calculate the minor of each of the elements of this matrix. If we want to calculate the minor for the element this 2, so this 2 is in third row and second column. So for that we write M3 and 2, M32. So M32, so we delete third row and second column. So we will remain with 4 2 4 and 3 6. So 2 4 3 6, and similarly we can calculate that. So this is how we can define the minor of the matrix. Now we will move for the next concept, that is cofactor of the matrix. Cofactor of matrix. So for defining cofactor of matrix, we will use the concept of minor. So we generally write cofactor by C. So Cij is equal to minus 1 to the power I plus j into Mij, where Mij is minor and I is row number and j is column number. So in this way we can define cofactor. So let's take another example for calculating the cofactor. This is one matrix, and if we want to write the cofactor for this, so this is in the position of 3 comma 1, so C 3 comma 2, 3 comma 3 2. So we will write minus 1 to the power 3 plus 2, and minor we have to write minor. So we delete this row and this column. So 1 3 2 3, this is our minor. So we can calculate minus 1 to the power 5, and this can be written as 3 into 1 minus 2 into 3. So this is minus 1 to the power 5, this is odd number. So this obtain we can get minus 1, and this is 3 minus 6. So finally minus 1 into minus 3. So this is equal to 3. So cofactor of this element, cofactor for this element is equal to 3. I hope you are getting the point. Now it's turn to define adjoint of matrix. Let A is a square matrix. That we can denote like adjoint of A, and it is defined as adjoint of A is equal to adjoint of A equal to Cij transpose. So, for defining adjoint of a matrix, we have to calculate all the cofactors and putting them into a matrix and take transpose of that matrix, and matrix obtained is called adjoint of the matrix. So, let us take an example. M is a matrix 2, 4, 3, 6. Now, we have to calculate each of the cofactor. So, one by one we are going to calculate the cofactor of each element. So, C11 is equal to minus 1 to the power 1 plus 1, and deleting first row and first column, we remain with 6. So, this is 6. So, if you calculate minus 1 to the power 2, that is 1, and this is 6. So, final answer is 6. Now, we calculate C12. C12 means minus 1 to the power 1 plus 2, and deleting first row and second column, we remain with 3. So, this is 3, and minus 1 to the power 3, that is minus 1, and this is 3. So, final answer is minus 3. Similarly, we can calculate 21, C21. For C21, we delete second row and first column. So, minus 1 to the power 2 plus 1, and we remain with 4. So, this is equal to minus 4. Further, we have to find C22. C22. For C22, we can delete second row and second column. So, we remain with 2, and we can write minus 1 to the power 2 plus 2, and here remain with 2. So, minus 1 to the power 4, that is equal to 1, and here is 2. So, finally, this is 2. Now, adjoint M. Adjoint M. Since we have taken the matrix M, so I am writing adjoint M. Adjoint M equal to transpose of cofactors. So, we write 6 minus 3 minus 4 and 2 transpose. So, we can write the transpose. So, for transpose, we can change the row into columns. So, 6 and minus 3, we can write 6 minus 3 in column, and this row is written in form of column. So, minus 4 and 2. So, this is our adjoint of matrix. I hope you are getting my point and you are able to understand the concept of adjoint of the matrix. Now, you are thinking that why we are calculating the adjoint of the matrix? What is the need to define the adjoint of a matrix? So, first need to define an adjoint of a matrix is to calculate the inverse of the matrix. So, if we want to define the inverse of matrix, we have to know the adjoint of the matrix, and also if we want to solve the linear equation of multiple variables like variable of 3 that contain x, y and z linear equations. So, solving them we need to calculate adjoint of the matrix. Now, take more example to understand the adjoint of the matrix. Example 2. So, in previous example I have taken a square matrix of order 2 cross 2. Now, I am going to take an example of matrix of order 3 cross 3, so that you can understand the concept in better manner. Let us take an example. Matrix A equal to 2, 1, minus 2, 3, 0, 4, minus 2, 2, 1. Now, this matrix contains 9 elements, and for each of the element we have to calculate the cofactors, and after calculating the cofactors we have to take the transpose. Now, calculate the cofactor for each of the elements. So, C11. So, for C11 we have to delete first row and first column. So, we remain with deleting first column or first row and first column, we remain with 0, 4, 2, 1. So, solve this. 0 into 1 minus 2 into 4. So, this is equal to minus 8, and minus 1 to the power 2, that is plus 1. C12. C12. So, delete first row and first second column. So, minus 1 to the power 3. I am writing directly since 1 plus 2 equal to 3. So, here deleting first row and second column, we remain with 3, 4, minus 2 and 1, and this is equal to minus 1 and 3 minus 8. So, this is equal to minus 1 into 11. So, this is minus 11. Now, C 13. So, for 13 delete first row and third column. So, minus 1 to the power 4. So, why I have written 4? Because I plus j, here comes I plus j, and I plus j 1 plus 3 equal to 4. I am writing directly. So, after deleting first row and third column, we remain with 3, 0, minus 2, 2. So, this is equal to 6. 3 into 2, 6, and minus 2 into 0, 0, and minus 1 to the power 4, 1. So, directly answer is 6. And further, we can determine for other elements C21. So, for C21, delete second row and first column. So, we remain with 1 minus 2, 2, 1. Minus 1, 1 minus 4. So, this is equal to minus 5. C 2, 2, minus 1 power 4, and after deleting second row and second column, we remain with 2 minus 2 minus 2, 1. So, this is equal to 2 minus 4. So, this is equal to minus 2. Okay, students. Now, you can find same for the other elements like 2, 3, 3, 1, 3, 2, 3, 3. So, C 2, 3 equal to minus 1 to the power 5 and 2 into 2, 4 minus 2 into minus 1. So, this is minus 1. And now, I am calculating directly. So, this is minus 5. C 3, 1. So, 3, 1. So, delete third row and first column. So, minus 1 to the power 4 and this is 4 into 1 minus 0. So, this is equal to 4. C 3, 2 minus 1 to the power 5. So, delete third row and second column. So, 4 into 2, 8 minus 3 into 2 minus 6. So, this is equal to 8 plus 6, 14. So, this is equal to minus 14. C 3, 3 minus 1 to the power 6. So, delete third row and third column. So, we will remain with 2, 3 and 1, 0. So, 2 into 0, 0 minus 3. So, this is equal to minus 3. So, finally, we calculated all the cofactor. So, this take long time and there involve lots of error. So, be cautious and be active while calculating all the cofactors. So, finally, adjoint A equal to write all the cofactors. So, minus 8 and minus 11 and next one is 6 and further minus 5, minus 2, minus 5, 4, minus 14, minus 3. So, adjoint A is equal to transpose of this matrix. So, finally, we can write minus 8, minus 11, 6, minus 5, minus 2, minus 5, 4, minus 14, minus 3. So, in this way, we can calculate adjoint of a matrix. I hope you understood the concept of adjoint of a matrix, and this will help you to calculate the inverse of the matrix. So, enough for today. Thank you.